Thank you.
Yeah, I like it.
Okay, let's have a little look at this. So we got solve this polynomial equation. And in order to solve a polynomial equation, what do we have to do to the left side here?
Divide by 3.
That would be a great idea if I could, but there's a 1 there. Okay. Otherwise, that would have been a great idea.
What are you solving for? Like x?
Solving for x, yeah. So how do we solve equations? How do we solve? What do you think, Darren?
You have to like do the diagonal.
Oh, is that thing?
Can we
That
Say it
box
again?
thing?
Can we get rid of all, like, the
whole
three goes into all those, right?
No, that's not right. We're not trying to evaluate. We're trying to solve for x here. Right now, let's just get your bearings here. Let's think about this. That means I got to find the value or values of x that are going to make that whole expression on the left side equal 0. Now, it's hopeless to just try to find those things by picking numbers out of the air, right? We've got a strategy for this, though. We did this in chapter 5. What do we do when we've got a great big expression that we got to...
do that a plus b times a minus b, or something like that.
I don't want a specific answer, but this is very basic stuff. I mean, this is the whole premise of what we did in chapter 5. So I want you to think about this, and you got to get this right, though. This is big. I mean, this is like the main thing we've talked about for
Factor.
3 months. Got a factor.
I
Yeah.
said factor.
Good. Yeah, we got a factor. I just didn't hear you. We got a factor, right? Because why would we have to do that? Well, we have to be able to break this thing up into small enough pieces where we can take each individual piece and find those zeros. This is too big an equation. We can't hope to get an answer to this. There is no magic formula for a 4th degree polynomial. But if we can break this thing down into pieces that are quadratic or linear, piece cake, right? Because I have magic formulas for those. I have the quadratic formula for quadratic factors, and linear factors are really easy to set equal to 0 and solve. We're going to use that zero product property. If I can split this up into a product of a bunch of factors, then I know that the only way I can multiply a bunch of things and get 0 is when those individual factors are equal to 0. And so I'll just set those equal to 0 and get my individual solutions. Okay? So we got to factor this thing. So when we start off to factor a big monster like that, what's the first thing we always want to try to do? Before we get specific and we look at the number of terms and look at our chapter 6 strategies, there's always a first step that we try.
Don't you like split them into 2 groups?
Oh yeah, we're going to. You're right. But before we even do that, greatest common factor. We always want to see if we can pull out a greatest common factor, because if we can do that, that's going to make whatever's left over a lot easier to deal with, right? So that's always our first step. Is there something that divides into each of those 4 terms? Okay. X does. You're right. There's no number. But look, each of these terms has some power of x. And therefore, I could take some power of x from each of those terms. Now, I can only take the weakest power of x, which is what? 1. This last term over here only has a single x to give up, but I can factor out that x. So I can undistribute or factor out the greatest common factor, x, leaving me with a whole bunch of stuff.
Do you happen to know where there's a breaker that gives me some power? My power belongs.
Over there?
Yeah.
No idea at all. Huh.
Somebody had the microwave on and everything shut down.
Really?
Yeah.
I'd call the office. Yeah, I have no idea.
Okay,
Yeah.
thanks.
You're an electrical engineer? So that's easy. So you can fix it.
That would be. I have no idea. Huh. It can't be in the room. So anyway, so what do we do? What do we do then? What are we left with if I pull that x out front? Okay, so this first term, if I divide away an x, I'm going to get 3x cubed. Second term,
9x squared plus x plus 3.
okay? And now inside the brackets, out in front of the brackets, we have one factor that's taken care of, right? He's done. This guy right here is done. But all this stuff we still have to deal with. Now we got to start thinking of our factoring strategies. What do we do if I've got an expression with 4
So
terms?
that's supposed to be like X outside of the parentheses?
Yep. And it's not, now this is this is just a matter of personal taste really, but I think it's a good idea not to use rounded parentheses there because they're too easy to get lost in the shuffle here. I would use like the squared off bracket, so it's pretty obvious that I've got this thing and then I've got all this stuff going on in here, okay? What do I do? What's my strategy if I want to factor something? 'Cause I'm not done. I got to keep going. I have to keep breaking that apart. A 4-term polynomial, what do we do?
Is this where you like drop it down and like cross over?
No, we've already
No,
tried that.
No.
Or is that what is that?
That's synthetic evaluation. We're actually, next section, we're going to find out that it's a lot more than that. But for now, it's just a way of evaluating a polynomial quickly. But there's a lot more to it that we'll soon discover. Somebody, what's our strategy for, what do you think?
What if we like break it into?
Group it. Yeah, we're going to group it into 2 groups. In fact, whenever we have an even number of terms, we're always going to break it into 2 groups. But we're going to limit ourselves to 4 terms. So then we're going to take this first group right here. In fact, I could even just do this. Being as I have a plus sign in the middle, how about if we just do this? I get the first group plus the second group, right? So it's grouped. Now, and here's something else I want you to really get used to. When you're doing algebra like this, I'm just going to move down vertically, and then each time I make a step downward on the page, I'm just making one algebra step, right? So now I've still got my x out front. I'm still working inside the brackets, but from this first group, what am I trying to do? And we can even set up the whole template here. I know that I'm trying to do something like this always, right? Okay, what are those things? What am I doing to this first group? Factoring out what? Greatest common factor. What is the greatest common factor of the first group? 3x squared. Good. That leaves me with what?
Wait, how'd you get that?
Plus
X
X.
plus-
Because now what's the biggest number that divides into 3 and 9?
2.
3.
3.
And what's the biggest common power of x? In other words, the weakest power of x would be x squared. Right? And so if I undistribute that, what does the first term give me?
X.
X. Second term? Plus 3. Okay, now remember, I know that for this to work, that has to be x plus 3, right? The question is just, can that work? Is there something that I can undistribute to get an x plus 3? Well, 1. I've already got an x plus 3. So it's a 1 in this case. Right? Okay? So now I've got the thing grouped. Yes, ma'am.
I'm confused. Because you have 3x cubed plus x squared. And I don't get how you get 3x squared.
Because I want to factor out the greatest common factor. So I got to break it into the numerical part and the variable part. What's the biggest number that goes into both 3 and 9? 3. So I can take a 3 out. That's the number part of my greatest common factor. What's the biggest power of x that I could tear away from those? Would be x squared, right? Because this one only has an x squared to give. Okay? So I can take an x squared away. And then what am I left with if I divide that out or factor it out or undistribute it? Okay? Make sense? Okay? And so then whatever I get for my leftover factor in the first group has to be my leftover factor in the second group. But it's not guaranteed. It's either going to work or it's not. The question is, can we get a greatest common factor from that second group that makes it work? And in this case, we could. A 1.
So you don't drop down the x plus 3, it just so happens to be the same?
Well, it would. Now, what if this had been something like x minus 3 up here? Let's just say what if. And I'm going to erase this in a second, but just pretend that was minus instead. Then I would have to have the same leftover factors, and so I'd put this x plus 3 here, but then the question is, could I find something that worked? Well, it would have to be 1 is the one we would try, right? Because 1 times x is x. But 1 times 3 is not negative 3, and so we would have just canceled it out and said, can't factor. Okay, that's a problem that we would not be able to do. Okay? But it worked out that we could. Okay, so now let's take everything inside the brackets and let's finish the factoring by grouping, because there's one more step there, isn't there? We've got inside the brackets, we've got the common factor in each term, x plus 3, so that's going to break into x plus 3 times what? If I factor out, if I pull an x plus 3, and here's another way to think about this that maybe is even, maybe you like this better. Let me do something here real quick. Actually, this is perfect. Would you agree that I've got this x plus 3 that's common to both of the two terms inside the brackets, right? So what if I take an x plus 3 and I pull that out front with the x? Okay. So I factor that out there also. Okay, now what is left inside the brackets if I do that? If I undistribute it?
3x squared plus 1.
3x squared plus 1. Exactly. Okay? And so I don't need to have those brackets. Those could just be parentheses now, right? I've got this factor down to where I've got 3 factors. I get x times x plus 3 times 3x squared plus 1 equals 0. It's broken down. Now, do I need to go any further?
Yes,
Why?
because there's
You gotta
squared.
multiply.
Okay, there's a squared, but big deal. Because if I set that equal to 0, I can just use the quadratic formula. Or isolate x or something, right?
No.
Now, I mean, there's really no, if I'm solving an equation, once I get it down to a quadratic form, there's no need for me to go any further. Because I can solve a quadratic, chapter 5 stuff. So now I get 3 separate equations, little mini equations I've got to solve. I traded this one great big monster for 3 small equations. So the first one, I want to know when are these 3 factors equal to 0? Because by the zero product property, their product equals 0 when each individual one equals 0, right? So what's the solution to the first factor?
0.
X equals 0. Or, what's the equation I get from the second one?
Negative 3.
Well, I'll just get x equals negative 3. Right? Or, the third one I've probably got to solve. I've got 3x squared plus 1 equals 0. Subtract 1. Divide by 3. Square root. So x equals,
Square root.
Nine.
forgot something, plus or minus
Plus or minus.
the square root of negative 1/3. But what are we doing when we have a negative?
Switch it. Switch it over. Get it to an I.
Make it an I.
Yep.
So then we get the solutions x equals plus or minus I times the square root of positive 1/3. So those are my 4 solutions. X equals 0, x equals negative 3, or x equals plus or minus I times the square root of 1/3. Now, if we were only looking for real solutions, how many did we get?
2.
2. We wouldn't have even counted that last one. And if I knew that we were only looking for real solutions, I could have bailed on this thing clear back here, couldn't I? Because I knew I was going to get an I. I have a square, x squared equals something negative, and so I could have just stopped. Right?
Deal.
Okay? All right. One more example I want to do. And then I feel like you guys are good for today and tomorrow in the lab. But I think there were some real questions on some of this stuff.
I get hooked.
Okay, let's do.
already in effect?
It's already in fact, yeah. As of date.
Oh,
Yeah.
that's good, because I don't have any
I know. So, like, Thursday, I'll work on
in terms of,
probably, or like, well.
Okay, here we go. Quentin, turn around.
probably gonna just go with you.
All right, here we go. Let's have a look at this. So here's another one, chapter 6 kind of thing. But this is really more like a chapter 5 problem. Because now, how many terms, now, we want to see if we can factor out a greatest common factor. Can we? No, can't this time. Okay. You know what I'm going to do though real quick? I just want to really make a point here. Because I didn't think ahead.
Really? I didn't.
Yeah, you don't need to, don't, you can leave it on your paper the way it is. It's fine.
Anyway, so what do you
Yeah.
No one ever chose.
Heads
No
down.
one ever done that way.
Let's face it, we're gonna
Dude, everyone got me like, it was so hard to have like 10
go.
Okay, so what about this one now? Is there a greatest common factor?
2.
There's a 2. Okay, but I got a trick for you. You could just factor the 2 out front, but being as I've got this thing set equal to 0, the factor 2 out in front, is that going to have any solutions?
Yes.
There's no variable in it, right? We only care about the factors that have variables in them. So here's a rule that could make life easier when you're solving equations at any level, polynomials, trig functions, anything. I can always divide both sides of an equation by a constant, but just not a variable. If I divide both sides by a variable, I would be losing factors and losing solutions. So that you absolutely can't do. That's a red flag. You never do that. But you can divide by a number or a constant. So what's a number that divides into all 3 of those coefficients? 2. So I could divide both sides of this equation by 2.
6, 5, 6.
And I'm going to get 12 over 2 is
6.
6. Oops. 6x to the 4th
To the fourth. Minus 5x squared.
minus 5x squared minus 6. 0 divided by anything is
0.
okay, right? So now we got this thing trimmed down. It's a little bit easier. Okay, but now we're kind of stuck with that. We can't factor out a greatest common factor. How many terms have we got there? Got 3 terms. So this is the only strategy we have for this, is to see if this matches a quadratic pattern. Does this match the pattern from chapter 5? In chapter 5 we saw stuff like this. A times, I'm not going to call it an x, but we're going to call it a different variable. Let's call our variable maybe like u. So a times u squared plus b times u plus c equals 0, where u is our variable. That was our quadratic pattern, right? Do we see something like that here?
Yes.
We do. A is 6, b is -5, c is -6, and u would be x squared, right? I can think of this in terms of packets of x squared instead of x, and then it looks like this pattern, right? So if this fits this, if a equals 6, b equals -5, c equals -6, and u equals x squared. Okay? Now we don't have to write all that down. We just have to recognize that. Yeah. Yeah.
Couldn't you, like, divide by x squared for the first 2?
Well, okay, you could, but dividing by something, or rather factoring something out, is only useful if we can do it from all the terms. Okay. Okay, so let's look at this again then. I've got this as, hey, over here, I need you guys to, this is distracting me, so it's got to stop. So I've got 6 times the x to the 4th, I'm going to write as x squared minus 5 times x squared minus 6 equals 0, right? And so now that's fitting our quadratic pattern, okay? Now, does this factor? Well, not easily, right? This is one where a is equal to 6, and so if you were solving this problem in chapter 5, would you have tried to factor this?
No.
What would you have done? You would have used the quadratic formula, right? The quadratic formula works here. right? Only instead of x equals negative b, it's going to be x squared equals negative b, right? Because this is written in terms of x squareds, not x's, right? Does that make sense? Okay. Now, if the original problem had been x to the 6th y cubed, then I could have thought of that in terms of packets of x cubed. X to the 6th would have been the same as x cubed squared, right? So you see the pattern here. The pattern is instead of the powers being 2, 1, and 0, they can be 2 times something, right? As long as these two numbers right here, this one is double that one, that same pattern is going to work. Okay? So then if we use now if I were to factor this, and some of these questions, there's one on the assignment that asks you to actually factor something like this where you're not solving it. If I were to do that, I would have to do the A times C split B thing and factor by grouping. But really, this is what we'll almost always be doing anyway. So let's just use the quadratic formula. So then our answer is going to look like x squared equals negative b. So what's that going to be?
5
Plus or minus
square root.
square root b squared.
Negative 5 squared.
Well, no, I never square negative.
Negative. You just
5
divide
squared minus 4 times 6 times negative 6
divided by 2.
12.
divided by 2 times 6,
12.
which is 12. Okay, so now let's just simplify this. So x squared equals 5 plus or minus.
25.
Let's get all this stuff in here down to a number. So that's going to give me, if I look at all the stuff in here, that's going to be a 25 minus a negative is plus. Remember, we count the number of negative signs. If there's an even number of negative signs, it becomes a plus. And then I'm just going to get, let's see, 36 times 4 would be 144. So I'm going to get a total of 169. Okay? All divided by 2 times 6 is 12. And so that equals 5 plus or minus, the square root of 169 is just 13, isn't it? Yeah.
I knew that.
And so I'm going to get two possible answers here. I'm going to get one for the plus and one for the minus, right? If I take the plus, I'm getting 5 plus 13 is 18,
Yes, sir.
right? 18 over 12. So that's going to give me x squared equals 18 over 12, which reduces to what?
9, 6. Right?
Or 3 halves. Good.
Yeah.
Okay. If I take the minus sign, I'm going to get x squared equals 5 minus 13, which is negative 8 over 12, which reduces to 2/3, negative 2/3,
There we go.
right?
So
And
that-
so now look, those are my two equations. I've got x squared equals 3 halves, or x squared equals negative 2/3. Let's look at both of those. So let me write them down before I forget them. X squared equals 3 halves, or x squared equals negative 2/3. We can solve both of those by just square rooting, right? What do I get over here if I square root? X equals, no, x equals, it's not the square root of 3 halves. It's,
Over 3. No.
no, I mean, what'd you forget?
What, man?
Plus or minus. The square root both sides, you have to put that plus or minus in there. That's important because there's two solutions.
So this answer gives, or that question gives 4 answers?
Yeah.
That's
Yeah.
crazy.
Or x equals, now what's this one
Plus or
going to be?
Plus
minus
minus.
square root.
Ah, good. I'm taking the square root of a negative. So I'm going to get I times the square root of 2/3. So I get 4 answers,
Yes.
right? Plus or minus the square root of 3 halves. Those are my 2 real answers in this case. And I get 2 imaginary answers. Plus or minus I times the square root of 2/3. Okay? Right? one's way easier though, isn't it, than the other one? I mean, all you had to, this is the same kind of problem you would have solved in chapter 5, only difference being that instead of just getting x equals 3/2 and x equals -2/3, it was x squared. So you gotta just do one extra step and square root both sides, right? We good?
Yes, sir.
Okay,
A
let's
little
go.
tricky though.
Is it worth going? Yeah, it's worth going.
Daniel,